Climate change is the most serious global issue of our time, and it has resulted in the aridification of land masses, as well as extreme weather events and changes to the water cycle. A minute 1% of all the water on Earth is freshwater, and out of that, 90% is locked up in Antarctica as ice, and a lot more is either too polluted or too difficult to access. This is why it is imperative that we limit our water consumption and carefully save precious freshwater. Saving water also has several cascading benefits on the environment, as it also saves electricity, gas, chemicals, and consumables involved in desalination. A lot of electricity goes into the process of pumping water, and chemicals such as chlorine are used for purification. Furthermore, desalination is very intensive in its use of energy and consumables, resulting in the discharge of pollutants. And water in households is generally heated before use by gas or electricity. This year's ROBOGALS major challenge prompt with KPMG was: how can humans work to better co-inhabit Earth with our natural environment? And the best way to do this is to use less resources. Hence, for my ROBOGALS major challenge, I decided to design a real-time water consumption feedback system, which alerts users of excess consumption and identifies the cause. Typically, in most Australian homes, there is an external water meter, and the billing cycle is every 2 months. The water bill shows total consumption and whether the household was water-wise or off track. Now, there are 2 issues with this. First, there is at least a 2-month delay in getting the data, and likewise a delay in corrective actions, whilst precious water is literally going down the drain. As best-selling author and management guru Peter Drucker put it, if you can't measure it, then you can't improve it. Secondly, there is no information as to who or what the culprit is. Is your sister enjoying long baths, or is it an ineffective appliance? A leaking tap, or a broken, badly timed reticulation system? For my project, I set myself a goal to reuse old items found in my house. The simple plan was to repurpose an old phone, download a mirroring app on it, connect it to a battering pack, and mount it in a plastic box to be placed over the water meter. This solar rechargeable light with an ambient light sensor would provide illumination at night. The actual implementation of this was quite straightforward, only using Velcro and tape to mount and secure the system. I first secured the battery pack and phone to the underside of the plastic box. Then I flipped this box over, placed it on top of the water meter, and placed the light on top of the box. With this setup, I could see the image of the water meter reading on my computer by an app called Let's View, which mirrors my phone screen to my computer, but this could be easily substituted with a baby monitor or a security camera.
For the next part of my project, I used Python, and here is a simplified snippet of my code. As my computer would receive images in real time, I used Python image library imaging processing capabilities to extract a small rectangle from the camera feed given coordinates on the screen for the meter readings, and then I used Tesseract, which is the Python's wrapper for Google Tesseract's OCR engine to convert image to text. Google's Tesseract OCR engine is one of the most accurate AI-enabled open-source engines. This would then write the output to Google Sheets, which could then be used to chart the water usage graph throughout the day. Through the application of my code, I was able to create a graph for my home's water usage over a 24-hour period and investigate the source of our excessive water consumption. As displayed in the graph, there was a significant peak from approximately 11 a.m. to 2 p.m., which is when we generally schedule our washing machine to run. Hence, it is clear that the washing machine was the culprit. Switching to a different washing cycle helps to significantly reduce our water consumption. From our graph, it was also clear that we were not suffering from any leaks, as there was no background water consumption throughout the day, and the other peaks corresponded to our showering and cooking times. As an extension, AI for graph analytics could be implemented to automatically identify patterns associated with causes for excessive water consumption, that is, long showers, leakages, inefficient appliances, and broken irrigation systems.
On this project, I have learned about Google Tesseract OCR AI, how to implement it into Python, and most importantly, water conservation. I participated in the ROBOGALS Science Challenge because I absolutely love it and think it's a wonderful opportunity to enhance my STEM skills and knowledge. Other students should definitely participate in the ROBOGALS Science Challenge because it's a great chance to learn lots and have fun. Thank you, bye!